will do the test in just a minute, but I am going to start there. Let me call up the Excel file and remind you how to find that scatter plot. We needed X and Y in order, so let me do that real quick. And, oh, whoops, did I just screw that up? I did. There we go. And I need the data analysis to go back again. Sorry about that. I would get really annoyed with having to do this every time, except that I know there are good reasons to wipe the computer every night. Okay. So actually, we didn't need that. We needed insert, the scatter plot, and scatter. And again, oh, I didn't tell it what data. So that was not good. And I need to increase this a little bit. I'm going to tell it those two columns. Actually, I'll tell it the exact data. So remember that if you're going to use the insert scatter plot, which again you will need for your homework for Monday, somebody just asked me, is there homework for not Monday, Wednesday? Maybe brief announcement. Remember the homework that was, online homework that was due Wednesday was due today, right? So the online homework that was due today is due Monday. So don't forget there's homework due Monday. There's not usually homework due Monday. It would have been due today. But I just wanted to give you the weekend. But on Wednesday, you'll need to do all of this, so take a note. To get the scatter plot via insert, you need to select the data in XY order, and since IQ is our X, I put it first. You go to insert, and then you pick the little picture that looks like a scatter plot up there. And this may be in your notes from last time, because we did this. And you click scatter plot, and there it is. The thing I wanted to show you extra is this plus. If you click it, the bottom option says trend line. And I'm going to add the trend line, and it has a little arrow to say you need to make another choice. Make it linear. Here's where you can do other things. And then click more options. Click more options. So click the plus, trend line, linear, more options. And at the bottom of more options, it says display equation and R squared on there. There they are. They come up in a little text box that you can move because usually it's right on top of the data. So that's how I got those. You will need to do that. So click the plus, add trend line, linear, more options, and at the bottom of more options it said add trend line, add R squared. So there it is, and this one is in MX plus D order. So the first thing in your new team activity is about this R squared. Is that the first thing? Okay, good. That's where we're at. Welcome back to the test. So we know R was, do you remember from last team activity what R was? That was the measure of strength, the correlation.
I've done it.
Was it 6337? Okay, if you square that number, you get R squared, which is 0.4016. This guy is purely a measure of strength of linear relationship. This guy, on the other hand, has a very specific interpretation. And it's written there on your team activity, and I'm going to say it out loud as you read with me. This, written in percent form, gives the percent of variability in Y due to variability in X. And I'm going to explain what that means. Do you see a bunch of different GPAs, a bunch of different Y values? Part of the reason there are so many different GPAs is because there are so many different IQs. Are there other reasons why people might have different GPAs besides IQ? Yes. But 40% of that variation in GPA is because of variation in IQ. You want to write that down in that space. 40% of the variation in GPA is because there's variation in IQ. That's what that means. 40% of the variability or variation in GPA is due to the variation in IQ. If we looked at only people with this IQ, you'd get less variation in GPA. But since we're looking at so many different IQs, we get so many different GPAs. So now you know the meaning of R squared. I'm going to go straight to the test, so I'm going to skip a little bit of your team activity. So actually, I'm going to go down to, so we'll talk about the other stuff later. Go down to the bottom of the first page where it says to test whether the relationship between X and Y is significant. I need to show you a few things, so you have to do this for your homework. All right. So, where was my hypothesis? Here. All right. So we're testing whether this is significant. The way you do that to determine whether a linear relationship is significant is you say, well, if I have no evidence, I have to say that the population slope, remember we called that beta, that's on your last team activity, beta 1. With no evidence, I have to assume the slope is 0. But we're going to see if there's evidence that beta 1 is, and you can say not equal or less than or greater than, but don't we generally think the higher the IQ, the higher the GPA? It's a reasonable assumption, so we'll agree to that. Okay, there are 4 assumptions we need to check, and the acronyms are on your team activity. The acronym to help you remember. You need to check 4 conditions to do this test. 1 is the pattern linear. Is it? Did we decide that already?
Yes.
Yes. Check. You look at the scatter plot. So I have on there how you check. Were the observations collected independently? You either have to be told that this is a random sample or assume random. N, we have to have normally distributed residuals. I'm going to show you how to check that. And equal, E stands for equal variation. I'm going to show you how to check that. So turn over the page. You have these 4 graphs. The first one is just the scatter plot. That's for L. We've already done that. We've looked at the scatter plot and determined linear. So if you want to write L somewhere, that's the linear check. I, independent, that's not a graph. That is the data randomly selected. N, normal residuals. You have to have one of these 2, and I'm going to ask you in your homework for both. Normal probability plot and histogram of residuals. I'm going to show you right now how to get those. Back in the data. Oh, sorry, thank you. Back in the data to do all the regression, we selected data analysis, regression, right? And we told it the Y's were the GPAs. So if you're needing to jot this down to remind yourself, please do. The X's were the IQs. I did include labels. We've done that before. I want you will as your homework, and I'll explain why later. You're going to click confidence level and put in 99. And then down here, you're going to click residual plot and normal probability plot. Residual and normal probability. Residual and normal probability. Any questions so far? And when you click OK on the next worksheet, this all comes up. We have done this before. We've looked at this summary output. Do you remember where in all that the regression line was?
Multiple R.
It's the coefficients, and there's intercept and IQ. The coefficient of IQ, that's the number in front of your X, that's the slope. So you should see there that negative 3.557, the 0.101, that's where those was. Those were. Okay. The ANOVA I told you we would never look at. But notice over here you get this graph, normal probability plot. That's how you get that one. All I want you to write down is it should be a straight line if it's normal. That's all I'm ever going to teach you about normal probability plots. I'm going to show you how to get that histogram of the residuals. If you scroll down, do you see this column that's titled residuals? Excel just sort of gives that to you. How would I make a histogram of it? Data analysis, histogram, click OK. Input, here's all the residuals. Those are all those little vertical subtractions for every single point. And we want a chart. Let's click OK. There it is. That's what is also on the back side. Do the residuals look normal to you?
Yes. Outliers.
No. So that N, normal residuals of the acronym line, that N is violated. What do we usually say if we're asked to do the problem anyway? Proceed with caution. By the way, these low values here are showing basically the same thing as in the normal probability plot. You see how this curves down at the end? Okay. So your homework for Wednesday is actually mini project 4. Oh, I know. All I can tell you is it is much easier than mini project 3. You have to demo this output, put it on a sheet, and bring it to class. You don't have to answer any questions. So the instructions will be posted within half an hour. Let's get this output, bring it to class.